This is Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So today we will discuss the methods of softening the hard water that can be used for the boiler applications. So, what are the different methods of softening of water? So, in the previous session, we have already discussed the internal methods or the treatments that can be used, like adding some chemicals to the water during the operation of boilers. So, now we will see the external methods like ion exchange, then the potable water and its specifications, and the breakpoint chlorination, some disinfection methods, and the reverse osmosis. So these are the some methods used in softening and disinfection of hard water and used for the industrial applications. So external treatment. In external treatment, ion exchange or deionization or demineralization is used. So there are different types of ion exchanges that are used, like cation and anion and cation. These are the copolymers of styrene and divinyl benzene. Styrene and divinyl benzene are the copolymers used as a cation anion and cation resins. So what is a cation resin? The resin containing acidic functional groups. So when it is having acidic functional groups like COOH or SO3H, these are the acidic functional group ending with H plus ions, are capable of exchanging their H plus ions with the cations present in the hard water and are called as cation exchange resins, and this is represented as RH plus. RH plus. Then the other one is the anion exchange resin. So there are some resins that contains amino or quaternary ammonium or quaternary phosphonium or quaternary tertiary sulfonium groups. So these groups are anion in nature, and when treated with the sodium hydroxide becomes capable of exchanging their OH minus ions. These OH minus ions present in these resins get exchanged with other anions like sulfate or chlorides that are present in the water. So these are called anion exchanging resins, and it is represented by ROH minus. So what is the process that is really taking place in the ion exchange method? So the hard water is passed through the cation exchange column. First, it is passed through the cation exchange column. This is the cation exchange column, and this is the anion exchange column. So when it is passed through cation exchange column, the cations like calcium and magnesium will be replaced. Calcium and magnesium will be replacing the H plus ions in the resins, and equivalent amount of H plus ions are released into from this column. So the water contains the H plus ions that are released from this cation resin. So this is the representative of the resin RH plus. With these ions, calcium and magnesium ions get replaced with calcium ion. The resin is replaced with calcium ion, and these H plus ions are released into the water. Released into water. So after this, the hard water is passed through anion exchange. So next happens is we are still calling it is as hard water because it is having anionic impurities like sulfate, chloride or carbonate. So these can be removed by anion exchanger. So what happens in the anion exchanger? Once it is completing the cation exchange, it goes and enters the anion exchange. So OH minus ion is released. The R group is the resin and OH ions. So the chloride will replace this OH ion, and the OH ion will be released into water. So this process takes place as the softening of water. So it will the outlet water will be the demineralized or deionized. So during this method, what happens? The ion exchange will get exhausted. How is it done? So this dark part is the blocked one, blocked with cations or the anions. Cations or anions. So this is, there will be some leakage. So because the cations or the anions are blocking the resins. So the cation exchanges are activated by mineral acid and anion exchanges by sodium hydroxide. Dilute sodium hydroxide. So this is the exhausted resin having calcium ions. So these calcium ions, when it is washed with or reacted with mineral acid, these H plus ions will replace the calcium ions, giving RH plus or the regenerated resin, and this calcium ions goes into the washings. So the column is washed with deionized water and washings. Calcium ions and magnesium ions are passed to sink or drain. So this is how it takes place in the calcium cation regeneration, cation exchange regeneration. And the exhausted anion exchange column can be regenerated by passing through solution of dilute sodium hydroxide. So the OH minus ions of this sodium hydroxide will replace the sulfate ions that are entrapped in the resin and forms regenerated anionic column and sulfate into the drain. So these are what are the advantages. The process can be used to soften highly acidic or alkaline water, and it produces very low hardness water, and it is very good for treating high pressure boilers. We are using soft water for high pressure boilers. So most of the cations and anions can be removed. Therefore, it is good for treating, helping using the high pressure boilers. Then what are the disadvantages? The equipment is costly due to usage of these resins. The equipment is costly due to these chemicals, and if it contains a turbidity, for example, if the water contains turbidity, then the output will be reduced, because the output will be reduced as it affects the percolation into the resin. So the turbidity must be maintained less than 10 ppm. Less than 10 ppm. Next, we will see what is potable water. So the type of treatment given to this water will depend on the quality of raw water that is present, and is depending on the impurities. So there are different steps that are used in treating this potable water. Removal of suspended particles, impurities. Screening, the raw water is passed through screens having large number of holes. It is just like a filter, that is, we are passing the hard water through these screens having large holes where floating materials are retained. Floating materials are retained on the filter and can be removed. Then the sedimentation. Here, if we see in this schematic, the sedimentation diagram. Sedimentation is a process of allowing water to stand undisturbed. So these are the impurities that are present, insoluble impurities. So if we keep it for standing for some hours, then it will sediment the suspended particles. So about 5 meters depth. So it will help in sedimentation. Then coagulation. This is other method where sedimentation along with coagulation is used to remove fine suspended particles. For example, if we are using filtration, fine suspended particles. For example, we have filters and holes, and the fine particles having size of these can penetrate through these holes and come out into the water. So that filtration cannot help. So coagulation will help in removing these fine suspended particles also. So it is done by coagulants, or the chemicals that are added to water before sedimentation. So we are adding some coagulants, chemicals that are added to the water. For example, alum. So these can be added into the water, and when it is added, there is some formation of flocks. So insoluble gelatinous flocculent precipitate is forming, which descend through the water adsorbs and entangles very fine suspended. So it will be entangled with the finely suspended, like it is forming like a particle, bigger particle. So the fine suspended particle increases its mass because of addition of this material, the chemicals. So this will happily settle down at the bottom of the vessel, bottom of the vessel. And the example is the sodium aluminate with water, so aluminum hydroxide and sodium hydroxide. So this will settle down. This will settle down. Down arrow indicates precipitation. So the aluminum hydroxide floc causes sedimentation, and the sodium hydroxide thus produces precipitate magnesium salts such as magnesium hydroxide. Magnesium salts such as magnesium hydroxide. So the other method is the filtration. So this filtration can help in removing the colloidal matter and most bacteria and microorganisms by passing through a bed of fine sand and proper sized granular materials. So this is the sand bed with sand corals or gravel. So there are layers of sand that is used and the gravel. So the top layer will be fine sand. So we will see in detail how the design is taking place. A sand filter consists of a top layer of fine sand placed over corals, sand layer and a gravels. So this is how the design is done. So we will see in detail. So for example, this is the sand filter. It is provided with an inlet of water. This is the inlet of water and a bottom of treated water. This is the treated water. This is the treated water outlet. Sedimented water enters the sand filter, is uniformly distributed over the sand bed. During filtration, the sand pores gets clogged. So when water is given into the sand filter, it is uniformly distributed. So during filtration, the pores of the sand will get clogged due to retention of impurities in the pores. So what happens? Ultimately, when it is getting clogged, the rate of diffusion reduces and it stops working. So before that, we have to understand that when it is stopping working, we have to remove 2 to 3 centimeters of this top sand layer to be scraped off and replaced with clear or clean sand, and the filter is put back into the usage. So this is how we can reuse the sand filter. Then the removal of microorganisms, it is nothing but the disinfection. It is a process of destroying or killing the disease causing bacteria, microorganisms, etc. from water and making it safe for drinking, or called as disinfection. So boiling is one of the method. Boiling is the simplest method we use daily in our daily life. Boiling for 10 to 15 minutes, all the disease causing bacteria can be killed and water can be used safely. Then the bleaching powder, this powder is like so bleaching powder can be used for purifying the water, like all the germs will be destroyed, wherein dissolving 1 kg of bleaching powder in 1000 kiloliters of water. This dissolved water gives a powerful germicide called hypochlorous acid. This is the hypochlorous acid that is forming, so that will kill all the germs. This is how bleaching powder can be used. Then the other method is the chlorination. For removing any microorganisms, chlorination is one of the method. In any form, chlorine is a big disinfectant that can be used. Whether it is hypochlorous acid, we are using like bleaching powder or chlorination, it is the chemical reaction is similar. Here we are using the chlorine gas directly. Chlorine gas directly. So the process of purifying the drinking water by producing a germicide like hypochlorous acid. So when this chlorine is mixed with water, it forms hypochlorous acid, and which kills the germs inside the water, in germs present in the water. So this is the hard water. Hard water. So once it is treated, it is forming chlorinated water. Chlorinated water. So chlorine is basic. It is having a pH more than 7. It is disinfectant and is much effective for the germs. So hence chlorine is widely used over all over, like powerful disinfectant. And the chlorinator is nothing but chlorinator. Chlorinator is the apparatus that is used for purifying the water. Then is the ozonization. Ozonization technique is the one technique we use for disinfecting the water having the germs or bacteria or microbes. So it is also a powerful disinfectant and readily dissolves in water. Readily dissolves in water. Ozone being unstable decomposes by giving nascent oxygen. Ozone is nothing but O3 that decomposes to oxygen and nascent oxygen. This nascent oxygen has property to react with, like it is capable of destroying the bacteria. This nascent oxygen also removes color and taste of the water and oxidizes all the organic matter present in water. All the organic matter present in water. So it has an advantage of most of the tough metals like manganese and iron also can be removed, and bacteria, virus and hydrogen sulfide, which is responsible for odor, rotten egg smell odor, hydrogen sulfide can be removed using ozonization. So this schematic shows the ozone generator and then pumping through the hard water and the purified water is coming out from the apparatus. Other method is a breakpoint chlorination. It is also a method, controlled process used for chlorinating the water. So in this process, suitable amount of chlorine is added to water. So in order to kill the bacteria in water, it entire organic matter has to be destroyed and to react. So this helps in destroying the organic matter, and it also reacts with free ammonia, the chlorine required. So the ultimate breakpoint indicates the amount of chlorine that is required for removing the organic matter and reacting with all the possible organic substances in the hard water. So the breakpoint determines whether chlorine is further added or not by chlorination. Organic matter and disease causing bacteria are eliminated completely, which is responsible for the bad odor and taste. So we will see in detail how the reaction will takes place. So when certain amount of chlorine is added to water, it leads to formation of chloroorganic compounds. So organics are present in water. So if we add chlorine, what forms? Chloroorganics. Chloroorganics. Simple. So the point at which free residual chlorine begins to appear. So whenever there is a reaction taking place, the chlorine free residual chlorine increases. I mean, it reduces. When there is no usage of chlorine further for disinfecting, the residual chlorine will increase. So this is the break point of that particular chlorine that is used. So once chlorine is added, there is a reduction in the residual chlorine due to formation of trihalomethanes reacting with trihalomethane, monochloramines, ammonia, iron, manganese nitrite, etc. So it will help in reacting with all these organic matter. So at one point it doesn't require any more chlorine to be disinfecting. Therefore, the residual chlorine will increase, and this is called the break point. The other method is the desalination of brackish water. The process of removing common salt from the water is known as desalination. Desalination, removal of salt. So the common salt is the sodium chloride that is present in high concentrations. So the water containing these dissolved salts is peculiar in taste, like with salty taste, and is called as brackish water. So desalination is a process where we can remove the salt Seawater is an example for this, wherein 3.5% of salts are present in the seawater. So it is totally unfit for the drinking process. Totally unfit for the drinking process. So there are some methods that are used to remove this salt, like electrodialysis and reverse osmosis. Electrodialysis and reverse osmosis. So we will see in detail how these methods will help. The reverse osmosis is most widely used, so we will see in detail. Before understanding what is reverse osmosis, we should know what is osmosis. What is osmosis? So when two solutions of unequal concentrations are separated by a semi-permeable membrane, then flow of solvent takes place from dilute to concentrated sites. Dilute to concentrated sites. So what happens? Uh, for example, this is a concentrated, low concentration. This is the high concentration. So what happens? There is a flow from dilute to concentrated site. Flow of solvent from dilute to concentrated site. This is called the general phenomena or the principle osmosis. So what happens in the reverse osmosis? It has to flow from concentrated to dilute. So reverse of this process. When does it happen? When is an applied pressure. Applied external pressure. This is used. Why we are trying to apply pressure and cause reverse osmosis? Because our water, hard water, contains high impurities, nothing but the high concentration of impurities. Therefore, we have to pass through this semi-permeable membrane from the high concentration to low concentration. So we need an applied pressure for doing this process. If you apply pressure, like hydrostatic pressure is applied in excess to the concentrated site, the solvent flows in reverse. That is, the solvent is forced to move from concentrated site to the dilute side, and this principle is known as reverse osmosis. So thus, reverse osmosis will give pure water, separated from its contaminants, rather than removing contaminants from the water. So this membrane filtration is known as super or hyperfiltration. So the outlet water is also known as RO water, nothing but reverse osmosis water. So this is the pressure we apply to the water, 15 to 40 kg per centimeter, to the sea water or the impure water, and this will help in leaving behind the dissolved salts or the organic or non-ionic form of that particular impurities. So what is this semi-permeable membrane consists of? Very thin film of cellulose acetate affixed to either side of a perforated tube. So there are some recently used ones are polymethacrylate and polyamide polymers. So these are the advanced ones which are used in the reverse osmosis. So we are treating the water, and RO water is used for further applications. So what are the advantages? It has distinct advantages like it can remove ionic, non-ionic, colloidal and high molecular weight organic matter. So at one shot it can remove all the organic and inorganic impurities like ionic, non-ionic, colloidal materials and high molecular weight organic matter from the water. And it also removes colloidal silica. This is some important advantage, because silica cannot be removed by any other method. So it can be removed silica. It can remove silica, which is not possible by deionization or ion exchange method. So the lifespan of membrane is quite high. We are it is separating so many impurities at a time, but still the lifetime is high, like about 2 years. And the membrane can be replaced with few minutes, thereby providing uninterrupted water supply. Low capital cost, simplicity, low operating cost, and highly reliable. So the reverse osmosis is gaining ground at present for converting seawater into drinking water and obtaining high water for the high pressure boilers, and can be used for further applications in the industries. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.